Since the launch of the James Webb Space Telescope, we have been anticipating so many things from it. And why shouldn't we? There is no question that the James Webb Telescope is the most powerful telescope ever built by mankind. In fact, its recent discoveries have shown that it is indeed the most powerful telescope ever built. Most recently, it has been able to show the edges of our universe. That's surprising, isn't it? So let's talk about the James Webb Space Telescope and its discoveries. Welcome to the Space Discoveries. Subscribe to the channel for every single detail about the new discoveries in the vastness of the space. Also, do not forget to hit that bell icon for new updates. Having said that, let's begin. So almost 13.8 billion years after the hot Big Bang, our universe is what it is today. Throughout the universe, galaxies are often clustered into galactic groups and rich clusters, separated by vast voids of mostly empty space. There is a mix of spirals and ellipticals, where a typical Milky Way galaxy forms about one new star every year. Additionally, most of the normal matter in the universe is hydrogen and helium, but about 1 to 2% is heavier matter from the periodic table, allowing for rocky planets like Earth to form complex chemistry. Although galaxies come in all kinds of shapes and sizes and colors, on average they are large, evolved, and clumped together. It's crazy how this universe grew into what it is today. As we look farther and farther away, looking at the universe from a distance, it looks less clumpy and more uniform, especially at larger distances. Our galaxies are smaller and less evolved. There are more spirals and fewer elliptical galaxies. And the James Webb Space Telescope provides the closest view of light in the universe that is otherwise invisible. But unfortunately, the scientists are not expected to see the first science images from the world's premier space observatory until the summer of this year. However, the latest test images taken by the telescope during its final commissioning phase provide a glimpse of what to expect in the future. At a press conference Monday morning, NASA's Goddard Space Flight Center in Greenbelt, Maryland, explained that these are the sharpest infrared images ever taken by a space telescope. Michael McElwain, project scientist for the Webb Observatory: "We have told that through the use of infrared light, Webb can peer into the atmosphere of exoplanets and see some of the first galaxies created after the universe began, which were invisible to the human eye at the beginning of the universe. These images were taken after the massive golden mirror segments of the telescope were successfully aligned. These test images illustrate clearly how well focused and clear the images captured by the observatory's 4 instruments are." However, the most remarkable result was the comparison of images taken of the same target by Webb's mid-infrared instrument with the now-retired infrared array camera from the Spitzer Space Telescope. Spitzer was one of the space telescopes used as part of NASA's Great Observatories program and was the first ever to be able to capture images of the universe in near and mid-infrared light with high resolution. And surprisingly, Webb's giant mirror and sensitive detectors are able to pick up even more detail than Spitzer, allowing for more discoveries than Spitzer could enable. Anyway, it is noted by scientists who have examined the 2 images of the Large Magellanic Cloud, a small galaxy neighboring the larger Milky Way, that Webb's image reveals unprecedented details of interstellar gas between the stars. Marcia Reker, who is the principal investigator for Webb's near-infrared camera and Regents Professor of Astronomy at the University of Arizona, said during the news conference that "You can appreciate the images from Webb are going to be better because we have 18 segments, every one of which is larger than the single segment, so to speak, that formed the Spitzer telescope's mirror." Later, he added that, "But it's not until you actually see the kind of image that it delivers that you really internalize and go, wow, just think of what we're going to learn. Spitzer taught us a lot. This is like a whole new world. We are now in the last phase of preparations before the Webb satellite will be able to begin conducting science observations." McElwain said that "I would call this the home stretch. We've had about 1,000 activities planned for commissioning, and there are only about 200 activities left to complete. Currently, the telescope's team on the ground is assessing the performance of each of Webb's instruments so that they can be ready to begin collecting data soon after they've completed their final checks and calibrations. There are about 4 or 5 science modes on each instrument that need to meet specific requirements. One of the features of Webb is the ability to track moving targets, which is particularly useful for scientists wishing to study objects in the icy parts of our solar system as they orbit the Sun. According to McElwain, when this phase is completed, we'll be ready to turn the science instruments loose on the universe. Moreover, according to Klaus Pontoppidan, who is Webb's project scientist at the Space Telescope Science Institute in Baltimore, said during the press conference that Webb's first images of the universe, called the Early Release Observations, or EROs, are expected to come out in mid-July. He later said that a more precise date will be shared later. Pontoppidan said that these first spectacular color images will demonstrate that Webb is fully operational and celebrate the beginning of many years of science to come. It has not been disclosed to the public what the exact targets of Webb are going to be for these first images because the telescope team does not want to spoil the surprise. In addition, those targets may change as the team gets closer to taking images. Pontoppidan said the first images will mirror what we are accustomed to seeing from the Hubble Space Telescope in terms of aesthetic quality. Moreover, during the press conference, Christopher Evans, project scientist of Webb at the European Space Agency, said, "Astronomy will never be the same again once we see what Webb can do with these first observations." In the coming months, scientists and engineers will be spending the next 2 months checking out and calibrating Webb's 4 science instruments, collecting test images and spectra to verify 17 different operating modes, before beginning its first season of science observations. Before that, however, the team plans to share a series of early release observations, or EROs, stunning images of spectacular astronomical targets that will illustrate Webb's ability to perform scientific research and, in the process, help justify its $10 billion price tag. As mentioned earlier, that NASA is keeping the list of potential targets under wraps, but plans to unveil the selected images and spectra of the selected targets at the end of July. Pontoppidan said that their objective is to demonstrate to the world and to the public that Webb is fully operational and that it produces excellent results. It's also an opportunity to celebrate the beginning of many years of Webb science. It is estimated that the selected targets, selected by an expert committee, will showcase all 4 science instruments to highlight all the Webb science themes, from the early universe to galaxies over time to the life cycle of stars to all other worlds. However, as we all know, to accomplish its razor-sharp focus, Webb's secondary mirror, equipped with ultra-precise tilt actuators, and its 18 hexagonal mirror segments that spanned its 21.3-foot wide primary mirror, each equipped with a precision tilt actuator, had to be precisely aligned with nanometer precision, an iterative process that merged 18 reflective beams into a single point. In order for Webb to detect the stretching out infrared light from the first stars and galaxies, it must operate within a few degrees of absolute zero, a feat made possible by a delicate 5-layer sunshade that deployed flawlessly shortly after the launch. There have been many changes since then. Mirrors and instruments have cooled to 390 degrees below 0 Fahrenheit, while MIRI, which has a high-technology cryocooler to enhance its ability to observe longer wavelengths, has reached minus 449 degrees, just 6 degrees above absolute zero. McElwain said, "Overall, the observatory performance has been phenomenal. We're really in the home stretch. At this point, we're characterizing and calibrating both the observatory and the science instruments. From my perspective, there are always risks going forward, but I have great confidence that we'll get to the finish line here, and we'll have a terrific science mission with tremendous scientific discovery in the next few months. So I'm just super excited to be at this point." Well, honestly, I think we're all super excited about this because who wouldn't want to find out what the mysterious answers of our universe are? Anyway, are you guys excited about JWST? Let us know in the comments. And that's it for now. Thank you for watching the video. If you liked the video, then don't forget to press that thumbs up button and also that hot red subscribe button. And we'll see you in the next video.